Are you experiencing difficulty in graphing quadratic functions? Then this tutorial video will be the solution. Welcome again in my channel wherein we are going to learn mathematics my way. So for today's session, I'm going to discuss how you are going to graph a quadratic function, and then when we graph quadratic function, we will also define, or we are also going to know what is a domain, range, intercepts, axis of symmetry, vertex, and the direction of the opening of the parabola. So let us start. So before we go to the graphing proper, let me first define some important terms that we are going to encounter. First term is parabola. So let me just recall to you that a parabola is the graph of a quadratic function and it is a smooth curve. So parabola, it could be opening downward. Please imagine my drawing is perfect. Or it could be opening downward. So that's a parabola. So that is just sketch. It's very hard to draw a parabola using a mouse, but later on I will show to you how we are going to sketch a nice parabola. Next term we are going to define is the vertex. Vertex is the turning point of the parabola. So now if we have a parabola, vertex will be located at this point. So this point, that's the turning point of the parabola, meaning at this point we are going to start to turn. So that's the turning point of the parabola. And additional information, if a is greater than 0, then parabola opens upward and has a minimum point. So if you are going to recall, the standard form of a quadratic function is y equals ax squared plus bx plus c. So the value of a here plays a very important role because it will determine the direction of the opening of the parabola. If a is greater than 0, meaning if a is positive, then the parabola opens upward and has a minimum point. So let me draw a parabola that is opening upward. Okay, that's it. And then we have the vertex at this point. So just imagine my drawing is beautiful. Hopefully the imagination will work. So if a is greater than 0 and the parabola is opening upward, it has a minimum point. So as you can see, when the parabola opens upward, the vertex is at the lowest point. That's why it's called the minimum point. And then if a is less than 0, meaning if a is negative, because there are cases wherein a is negative, the parabola opens downward. And this is the graph. The parabola opens downward, and the implication is it has a maximum point. So as you can see, when the parabola is opening downward, the vertex is at its highest point. That's why it's called the maximum point. Next. Next term we are going to define is the axis of symmetry. So axis of symmetry, that is the line which divides the graph into two parts such that one half of the graph is the reflection of the other half. Now, so if I'm going to draw a parabola opening upward, and then the axis of symmetry is located at this point, passing through the vertex. So just imagine that my drawing is perfect. So axis of symmetry, if you are going to look at this drawing, this part is exactly the reflection of the other part. So that's the purpose of the axis of symmetry. Next, it is given by the equation x equals h. So where can we get the value of h? So just recall, if we have the standard form, we also have the vertex form, and in the vertex form, we have this variable, the h and k. But for the axis of symmetry, it should be x equals h. And if you can recall, during your grade 8, x equals any constant, that is a line, a vertical line, passing through that value of h. So it's a vertical line. Domain. Domain are all permissible values of x. So if you can recall, for a function, it talks about dependency. So for the domain, it pertains to x, meaning domain is the set of all the independent variable, the x, all possible values of x. And for a quadratic function, the domain of a quadratic function is the set of all real numbers. So every time you are asked to give the domain of a quadratic function, the answer is always this one, the set of all real numbers, or in symbol, you can write x and the element of the set of the real numbers. So that's it. Again, domain of a quadratic function is the set of all real numbers. So you can write that in words or in symbol. Next, if we have domain, we also have range. If x is the domain, range is for y. So we define range as the corresponding values of y with respect to the domain. So every time we have a domain, we also have a corresponding range. And for quadratic function, it depends on the direction of the opening of the parabola, and we only have two directions. It's either opening upward or opening downward. So if the parabola is opening upward, we use this inequality. Y is greater than or equal to k, that is for upward. Now if the parabola is opening downward, we use this inequality. Y is less than or equal to k. And that's very easy to memorize. If upward, you use greater than or equal to. If it's downward, you use less than or equal to. Okay, so those are the terms, important terms you need to internalize so that we can perfectly sketch a quadratic function. So let's have example. I will only give one example so that this video will be just short, because if the video is too long, you might be feeling sleepy. So I'll just have one example, hoping that you will also watch this video. Example, sketch the graph of f of x equals negative x squared minus 2x minus 3. So I am just using the word sketch. This is playing safe, because if the drawing will become ugly, then we can say because it is just a sketch. Okay, first thing we are going to do, this is my way of graphing a quadratic function. I think this is a comprehensive way, so just observe the example. First thing we are going to do is to find the vertex of this given quadratic function. F of x equals negative x squared minus 2x minus 3. If you were able to look at in one of my tutorial video, I already solved the vertex of this function. So I will just replay the video and then just take note, how did we get the vertex? F of x is equal to negative x squared minus 2x minus 3. And again, I prefer using the vertex formula, so I am going to identify the values of a, b, and c. A is equal to negative 1 because of this sign. This sign. this side. Okay, b is equal to -2 and c is equal to -3. They are all negative. Why are you like that? You should be positive in life. Okay, they are all negative. H is equal to -b over 2a. Just substitute and simplify. So you will have negative, and be careful because b is -2, so you write -2. And on the denominator, you will have 2 times -1 because a is equal to -1. And simplifying further, negative times -2 is equal to +2. And 2 times -1 is equal to -2. And then positive divided by negative is equal to negative. That's why we are going to have h as -1. Magic square, rectangle there. Magic rectangle. Next, we are going to find the value of k. 4ac minus b squared all over 4a. So substitute, and simplify. So 4 times -1 times -3 minus, again, enclose b in a parenthesis, it's negative, so that we will not have confusions later. In the denominator, we have 4 times -1. 4 times -1 times -3, we have 2 negatives, so that will become positive, right? So 4 times -1 is -4 times -3 is positive 12 minus -2 squared is equal to 4. And on the denominator, we have 4 times -1 is -4. And simplifying it further, 12 minus 4 is equal to 8 over -4. And finally, we have k is equal to -2, magic rectangle. So based on the video, we get the vertex. Vertex is given by the coordinate -1, -2. So again, we write coordinate in this form with the parentheses. We have -1, -2. So vertex, that is hk. So value of h is -1. Value of k is -2. So after getting the vertex, we will have the Cartesian plane, the x-axis and the y-axis. So let us label this one as the x-axis and this one is the y-axis. So that's very important. Now we are going to plot the vertex. That's -1, -1, -1. So we have -1 and then -2. So we have the vertex at this point, -1 and -1, -2. That is the vertex. Next is we have the axis of symmetry. So from the vertex, we can have the equation for the axis of symmetry. And that is given by the equation x equals -1. So again, as I said earlier, when we have this type of equation, it is a vertical line passing through -1. So we have -1, and then we are just going to draw a vertical line. And that is the axis of symmetry. So the axis of symmetry plays a very important role in sketching the graph so that we can have a graph that is very near to a perfect graph. After that, we are going to construct table of values. So this is where the importance of axis of symmetry will come out. So in your table of values, the vertex is one of the pair. So h is the value of x, so that's -1. And then for k, that is for y. And then I'm going to put that one in the middle of the table. So I want to have 5 pairs. In the third pair, I choose the vertex so that it will be evenly distributed. Now, the purpose of the axis of symmetry, we are going to get values of x. Again, x is independent, so we are the one who are going to choose the values of x. But in order for our graph to be symmetric, we need to pick x values of the same distance from the axis of symmetry. For example, this is the axis of symmetry. And then I'm going to choose 0. So from the axis of symmetry, we have 1 unit to 0. So if I'm going to choose 0, on the other side of the axis of symmetry, I will also move 1 unit. So that is negative 2. That's why I will have negative 2. Now moving on, that's 1 unit. So I decided to move 2 units from the axis of symmetry. That is positive 1. On the counterpart, on the other side, I will also move 2 units. 1, 2. So that's why I will have negative 3. Now the values of x will depend on the vertex. Where is the vertex located? And then you use the purpose of the axis of symmetry to make your sketch symmetric. So after that, we are just going to substitute. So for example, if x is equal to 0, we are just going to substitute that one to our given equation. We have y equals negative, so x is 0, so that will become 0, 0 squared minus 2 times 0, 0 minus 3. So basically, if we are going to substitute 0 on this one, what will remain is negative 3. So if x is equal to 0, our y is equal to negative 3. And what is nice with this method of constructing table of values, automatically what value we get from this 0, we automatically put this value to the corresponding value that we choose earlier. So if from the axis of symmetry we move 1 unit, on this side we have 0, and then on this side negative 2, 1 unit, then meaning if x is equal to negative 2, y is also equal to negative 3. So it makes our works faster and easier. Now if x is equal to negative 1, we are just going to substitute y equals negative. So value of x is 1, so enclose that 1 in parentheses to avoid mistakes. Negative 1 squared minus 2 times 1 minus 3. Now what is 1 squared? That is positive 1, but we have a negative sign on the outside of the parentheses. That's why it's still negative 1. Negative 2 times 1 is negative 2, and then we have minus 3. So if you can see, they are all negatives. We can combine the values. 1, 2, and 3, that is 6. So we will have negative 6. So if x is equal to 1, y is equal to negative 6. Now, using the same pattern earlier, we can also write negative 6 when x is equal to negative 3. Well, see, diba? It's faster, right? Now, after having the table of values, we are now going to plot the pair of points, the coordinates. So we start with 0, negative 3. 0, negative 3 is at this point. 0, negative 3. Next is 1, negative 6. 1 and then negative 6. So we have this point. Next, on the other side, we have negative 2, negative 3. So we have negative 2, negative 3. And then the next pair, we have negative 3 and negative 6. Now, the points are ready. What we are going to do now is to connect But make sure you have a smooth curve from the vertex because this is the turning point. So we have our parabola. So again, we are just sketching, so do not expect we will have a very nice sketch. So at least it looks decent and beautiful. Now we have our parabola. So we are going to name our function, our graph, that is f of x is equal to negative x squared. Make sure your graph have names. Minus 2x minus 2x minus 3. So that is the name of our function. And then from this graph, we can now determine the direction of the opening and then whether the vertex is a maximum or minimum point. But earlier, if you are going to look at the function, a is equal to negative 1. So given the function already, you should already have the idea that since a is equal to negative 1, the parabola should opens downward. It should be opening downward because a is equal to negative 1. And so what if it's opening downward? It will imply that vertex is a maximum point. As you can see on our sketch, the vertex is at its highest point, therefore it is a maximum point. Next that we are going to have is the domain. Domain, as I said earlier, the domain is always the set of the real numbers. The set of all the real numbers. Now for the range, since the vertex or the parabola is opening downward, that's why we are going to use the symbol less than or equal to. And then we have y. So for the range, we have y is less than or equal to. Y less than or equal to because the parabola is opening downward. If it's opening upward, then you use greater than or equal to. Then what we are going to supply is the value of k. K is equal to negative 2. That's why for the range, y is less than or equal to negative 2. Meaning, if you are going to look at the graph, the values of y that can be used started with negative 2 moving downward because y is less than or equal to negative 2. Meaning, negative 1 cannot be hit by the parabola. Same as 0, same as positive 1, and so on. Again, for the domain, x is element of the real numbers, meaning all these values of x are possible values of x. So we can have positive 3. So if we are going to extend our parabola, it will surely hit when x equals 3. Now, additional information, when we have y-intercept, if you are asked to give the y-intercept, just look at the graph. Y-intercept is equal to, just look at the graph where it hits the y-axis. So it's very clear it hits the y-axis on negative 3. Or even if without the graph, just look at the function. The value of c is also the y-intercept. So we have y-intercept is negative 3. For the x-intercept, the same idea. You are going to look at where the graph touches the x-axis. But in this case, no matter how you are going to extend our parabola, it will not hit or it will not touch the x-axis. Meaning, in this problem, there are no x-intercept. So we can write no x-intercept, or we can have an empty set, meaning there are no x-intercept. So again, to sum up, in sketching the graph of a quadratic function, you start with finding the vertex. After that, you draw the axis of symmetry, and then you construct table of values so that you can graph the parabola smoothly. And then this one, if you are just paying attention to the previous slides, you can answer this easily. Now for the y-intercept, again, you look at the value of c, that's to the y-intercept. For x-intercept, you can use what you have learned during the first cycle. You equate this one to 0 and then solve the quadratic function. So it's either you are going to use factoring or the quadratic formula. If it is not factorable, you use quadratic formula, and always expect that there are two answers. There are two answers. For this one, there are two answers. The only problem is they are not real numbers. The x-intercepts are not real numbers because they are not intersecting, or they are not touching the y at the x-axis. So I hope you learned something today. Thank you for watching this video.